To determine if the wiring in your home is rated for 90 degrees Celsius, there are several steps you can take. Firstly, look for labels or markings on the wire itself or on the electrical panel. These labels should specifically state 90°C or 90 degrees Celsius. Secondly, check the wire color. While not a definitive indicator, 90°C wire insulation is typically white or off-white. In contrast, 60°C wire insulation is often black or red. However, be aware that some 60°C wires can also be white, so this method isn't foolproof. Thirdly, examine the wire thickness. 90°C wire is generally thicker than 60°C wire of the same gauge. This is because the thicker insulation provides better heat protection. Fourthly, inspect the electrical panel. If the panel is original to the house, meaning it was installed around the time the house was built, it might have markings or labels that indicate the wire rating used during the initial installation. Fifthly, research local building codes. While homes built after 1985 are generally required to have 90°C wire, it's possible that different building codes were in effect in your area at the time your home was constructed. Consult local building department records to verify the specific code requirements that were in place during that period. Sixthly, consider testing the wire. A qualified electrician can use a specialized tester to accurately measure the temperature rating of the wire. This is the most reliable method for determining the wire's actual rating. If the ceiling light fixtures are also from the same era as the house, it is likely that they are not compatible with 90°C wire. In this case, it's best to replace the wiring or fixtures to ensure safety. If you are unsure about the wire rating, it's always recommended to consult a qualified electrician. Working with electrical systems can be dangerous, and it's crucial to have a professional verify the safety of your wiring before making any changes. Electrical work can be hazardous, and it is best to leave it to trained professionals. Ensure the power is shut off before working with any electrical circuit. Wear safety glasses and gloves while working on electrical projects. Ensure the area is dry while working on any electrical project. Always consult with a qualified electrician before starting any electrical project. Understanding wire gauges is essential for safe electrical work. Wire gauge refers to the physical diameter of the wire. The American wire gauge, or AUG, is the standard system used in the United States for measuring wire size. The smaller the AWG number, the larger the wire diameter. For example, a 12 AWG wire is larger than a 14 AWG wire. Different wire gauges are designed to carry different amounts of electrical current safely. Using a wire gauge that is too small for the intended current can cause the wire to overheat, potentially leading to a fire. The National Electrical Code, NEC, provides guidelines for the appropriate wire gauge to use for various applications. These guidelines take into account the amperage of the circuit and the type of insulation on the wire. Common wire gauges used in residential wiring include 12 AWG and 14 AWG. 14 AWG wire is typically used for 15 amp circuits, while 12 AWG wire is used for 20 amp circuits. When running wire through walls or ceilings, it is important to protect the wire from damage. This can be done by using conduit or cable staples. Conduit is a metal or plastic pipe that protects the wire from physical damage and moisture. Cable staples are used to secure the wire to studs or joists. When connecting wires to electrical devices, it is important to make sure the connections are tight and secure. Loose connections can cause the wire to overheat and potentially lead to a fire. Use wire connectors, such as wire nuts or crimp connectors, to make secure connections. Always follow the manufacturer's instructions when using wire connectors. When working with electrical circuits, it is important to identify the different types of wires. The most common types of wires are hot wires, neutral wires, and ground wires. Hot wires carry electrical current from the power source to the device. Neutral wires return the current from the device to the power source. Ground wires provide a safe path for electricity to flow in the event of a fault. Hot wires are typically black or red. Neutral wires are typically white. Ground wires are typically green or bare copper. It is important to never mix up the different types of wires. Connecting a hot wire to a neutral wire can cause a short circuit, which can be dangerous. When working with electrical circuits, it is important to use the correct tools. Some essential tools for electrical work include wire strippers, pliers, screwdrivers, and a multimeter. Wire strippers are used to remove the insulation from wires without damaging the wire itself. Pliers are used to grip and manipulate wires. Screwdrivers are used to tighten and loosen screws. A multimeter is used to measure voltage, current, and resistance. When using electrical tools, it is important to follow the manufacturer's instructions and take safety precautions. Wear safety glasses and gloves to protect yourself from injury. Make sure the tools are in good working condition before using them. Never use electrical tools in wet conditions. When working with electrical circuits, it is important to follow the National Electrical Code (NEC). The NEC is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and best practices. Following the NEC helps to ensure that electrical installations are safe and reliable. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to consult the NEC when planning and performing electrical work. When working with electrical circuits, it is important to understand overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current. Circuit breakers and fuses will trip or blow when the current exceeds the rated value, interrupting the flow of electricity and preventing damage to the wiring and equipment. It is important to use the correct size overcurrent protection device for the circuit. Using an overcurrent protection device that is too large can allow excessive current to flow, potentially causing a fire. The NEC provides guidelines for the appropriate size overcurrent protection device to use for various applications. When working with electrical circuits, it is important to understand grounding. Grounding provides a safe path for electricity to flow in the event of a fault. Grounding helps to prevent electrical shock and equipment damage. Grounding systems typically consist of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the electrical system to the grounding electrode. It is important to ensure that the grounding system is properly installed and maintained. The NEC provides guidelines for the installation and maintenance of grounding systems. When working with electrical circuits, it is important to understand voltage drop. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. Voltage drop can be caused by the resistance of the wire, the length of the wire, and the amount of current flowing through the wire. Excessive voltage drop can cause electrical equipment to malfunction or operate inefficiently. It is important to minimize voltage drop by using the correct size wire and keeping wire runs as short as possible. The NEC provides guidelines for calculating voltage drop. When working with electrical circuits, it is important to understand the different types of electrical boxes. Electrical boxes are used to enclose and protect electrical connections. There are many different types of electrical boxes, including metal boxes, plastic boxes, and weatherproof boxes. Metal boxes are typically used for indoor applications where durability is required. Plastic boxes are typically used for indoor applications where corrosion resistance is important. Weatherproof boxes are used for outdoor applications where protection from the elements is required. It is important to use the correct type of electrical box for the application. The NEC provides guidelines for the selection and installation of electrical boxes. When working with electrical circuits, it is important to understand the different types of wiring methods. There are many different types of wiring methods, including non-metallic sheathed cable, armored cable, and conduit. Non-metallic sheathed cable, also known as Romex, is a common type of wiring used in residential construction. Armored cable, also known as BX, is a type of wiring that is protected by a flexible metal sheath. Conduit is a metal or plastic pipe that protects the wires from physical damage and moisture. It is important to use the correct type of wiring method for the application. The NEC provides guidelines for the selection and installation of wiring methods. When working with electrical circuits, it is important to understand the different types of electrical receptacles. Electrical receptacles, also known as outlets, are used to provide a connection point for electrical devices. There are many different types of electrical receptacles, including standard receptacles, ground fault circuit interrupter receptacles, and arc fault circuit interrupter receptacles. Standard receptacles are used for general-purpose applications. Ground fault circuit interrupter receptacles, or GFCIs, are used in areas where there is a risk of electric shock, such as bathrooms and kitchens. Arc fault circuit interrupter receptacles, or RFCIs, are used to protect against electrical fires caused by arc faults. It is important to use the correct type of electrical receptacle for the application. The NEC provides guidelines for the selection and installation of electrical receptacles. When working with electrical circuits, it is important to understand the different types of electrical switches. Electrical switches are used to control the flow of electricity to electrical devices. There are many different types of electrical switches, including single-pole switches, double-pole switches, and three-way switches. Single-pole switches are used to control a light or device from a single location. Double-pole switches are used to control a light or device from two locations. Three-way switches are used to control a light or device from three or more locations. It is important to use the correct type of electrical switch for the application. The NEC provides guidelines for the selection and installation of electrical switches. When working with electrical circuits, it is important to understand the different types of lighting fixtures. Lighting fixtures are used to provide illumination. There are many different types of lighting fixtures, including incandescent fixtures, fluorescent fixtures, and light-emitting diode fixtures. Incandescent fixtures are the oldest type of lighting fixture and are known for their warm, yellowish light. Fluorescent fixtures are more energy efficient than incandescent fixtures and produce a cooler, bluish light. Light-emitting diode fixtures, or LEDs, are the most energy efficient type of lighting fixture and can produce a variety of colors. It is important to use the correct type of lighting fixture for the application. The NEC provides guidelines for the selection and installation of lighting fixtures. The ampacity of a conductor is the maximum amount of electrical current it can carry continuously without exceeding its temperature rating. Ampacity is measured in amps. The ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, and the ambient temperature. Larger conductors have higher ampacities than smaller conductors. Conductors with higher temperature ratings have higher ampacities than conductors with low temperature ratings. The NEC provides tables that list the ampacities of various conductors under different conditions. It is important to select a conductor with an ampacity that is sufficient for the load it will be carrying. Overloading a conductor can cause it to overheat, which can lead to a fire. The NEC requires that conductors be protected by overcurrent protection devices, such as circuit breakers and fuses. The overcurrent protection device must be rated to protect the conductor from overloading. The overcurrent protection device should not be rated higher than the ampacity of the conductor. For example, a 14 AWG copper conductor with type TW insulation has an ampacity of 15 amps. This conductor should be protected by a 15 amp circuit breaker or fuse. A 12 AWG copper conductor with type TW insulation has an ampacity of 20 amps. This conductor should be protected by a 20 amp circuit breaker or fuse. Table 310.15.16 in the NEC provides ampacity ratings for conductors rated 0 through 2000 volts. This table takes into account the conductor size, insulation type, and ambient temperature. Correction factors are applied to the ampacity ratings in Table 310.15.16 to account for situations where the ambient temperature is higher than the temperature listed in the table. Adjustment factors are applied to the ampacity ratings in Table 310.15.16 to account for situations where multiple conductors are bundled together. Bundling conductors reduces their ability to dissipate heat, which reduces their ampacity. It is important to consult the NEC to determine the appropriate ampacity for conductors under different conditions. Choosing the right wire size based on ampacity is crucial for safety. Undersized wires can overheat and cause fires. The National Electrical Code (NEC) provides tables to determine the correct wire size for different ampacities. Consider the length of the wire run. Longer runs have greater voltage drop, so a larger wire may be needed. Account for ambient temperature. High temperatures reduce a wire's ampacity. Consider the number of current-carrying conductors in a conduit or cable. More conductors reduce ampacity. Always consult the NEC for specific requirements and regulations. When in doubt, it's always best to consult a qualified electrician.